Hello dear friends, welcome to MACS College. Now in this session we learn how to find determinant of a matrix, inverse of a matrix, and very importantly we learn definition of rank. Please note the method to find rank is very simple, but the definition is depending on the determinant of the matrix. So because of that we are putting all these in one session. So in this session you can expect following questions covered, like finding determinant of the matrix, adjoint of the matrix, and inverse of the matrix. Then we learn the definition of the rank. Please note here we are only giving definition of the rank. Okay. Later on we learn how to find rank of the matrix, which is very simple based on echelon form of the matrix. Okay. Here we are interested in definitions. For that the concept of determinant is important. Determinant of 1 by 1 matrix is the element itself. If it is a 2 by 2 matrix, please note it is not absolute value, it is determinant. The determinant is given by AD minus BC. For example, if you are having a matrix say 5, 6, 4, 3, then what is determinant of the matrix? 5 3s 15 minus 4 6s 24. So what is the answer, my dear friends? Minus 9. Some people feel determinant cannot be negative. It is not like that. Determinant can be negative also. Please note. Now to find 3 by 3 determinant, we need to understand concept of minor and cofactor. Of course, there is a shortcut for 3 by 3 determinant. I will give you later, but it is very important to know these definitions, which are very simple. It is called minor of ith row jth column element, ijth element. Let me explain. First we will try to learn how to find minor for few elements, then how to find cofactors, then we finally learn how to find cofactor matrix. So ultimately we are interested in finding cofactor matrix. Okay, first of all let us find minor. Now I want minor of this element. This element is in the second row, third column. So whenever you want minor of any element, remove the row and remove the column. The remaining submatrix determinant is minor. 1 2 2 1. Remaining submatrix determinant is minor. So 1 minus 4, that is minus 3. Similarly, you want minor of any element. Suppose you want minor of say 3 1. Third row, first column element. Remove the row and remove the column. Remaining submatrix determinant, that is 2 4 1 2, determinant is minor. So 4 minus 4, this is 0. Similarly, you can take any element, we can find minor of the element. For example, if you want this, which is in the first row and second column. So here remove the column and remove the row. Remaining submatrix determinant, that is 3 2 2 1 fellows determinant, which is 3 minus 4, yani minus 1. Similarly, we can find minor of every element. Now comes cofactor. Cofactor of Aij, that is ith row jth column element. So cofactor is called signed minor. What is it? It is minus 1 power I plus j into minor. You already know how to find minor. That is multiplied with this minus 1 power I plus j. So it is actually a sign, minus 1 power. If I plus j is even, you get plus sign. I plus j is odd, you get minus sign. And you know, for every element, for example, if it is A11, A12, A13, A21, A22, A23, A31, A32, A33, for every element this sum is already known. 1 plus 1 is 2 even. So, you get plus sign. 1 2 you get minus sign. So, fixing this sign is very simple. So, mainly we are finding minor only. So, let us see how to find cofactors of few elements. For example, let us find cofactor of this second row third column element. So, it is a signed minor. Obviously, M23 will be there with a sign. What is that sign? 2 plus 3 odd. It is like, you know, minus 1 power 2 plus 3, which is minus 1 power 5, which is minus 1. But don't waste time. If sum is odd, you get minus sign. And you already know how to find the minor. For minor, you have to remove the row and column. Remaining submatrix determinant, that is 1 into 1 minus 2 into 2, that is 1 minus 4, that is minus 3. Minus of minus 3 plus 3. You can take any other element, my dear friends. We can find cofactor of that element. For example, you want cofactor of this element, which is in the first row, third column. 1 plus 3 is even, so you get plus sign. So, it is plus M13. Minor only we are finding, only that sign is extra. Remove the row and remove the column. So, 3 minus 2, which is 1. So, cofactor is 1. Hope you understand. Now, let us find the entire cofactor matrix for this matrix. That is, we want cofactor of every element and you want the cofactor matrix. But whenever you want cofactor matrix means what? A matrix with all the cofactors. Now, in the cofactor, the sign is already known. The sign is already known. For example, 1 1 element, it is plus sign. 1 2 odd, 1 plus 2 is odd, so it is minus sign. 1 3 even, that is 1 plus 3 is even, so plus sign. 2 1 is odd, minus sign. 2 2 is, that is 2 plus 2 is even, plus sign. 2 3, 2 plus 3 is odd, minus sign. So, alternatively you get plus minus sign like this. So, signs are fixed. We just need to find minor of each element and keep it here. Because sign is already available, only we just need to find minors for each element and substitute here. Then you get cofactor matrix. Okay. So, what we do now? Let us find minor of each and every element. So, minor of this element, remove the row, remove the column. 1 minus 2, that is minus 1. Okay. So, you can do it with pencil, or you can do it like, you know, blindly. You can close with your fingers, you can close this row and you can close this column. Then 3 minus 4, which is minus 1, like that. Here I am showing it, but you can just close it with your fingers. Column and row removed. So, 3 minus 2, which is 1. So, whatever element you want, for whatever element you want to find minor, the corresponding row and corresponding columns to be closed. So, you close the row and you close the column. So, 2 minus 4, it is minus 2. Close the row and close the column. 1 minus 8. 1 minus 8 is how much? Minus 7. Next element. Remove the row and remove the column. 1 minus 4, that is minus 3. Next element, remove the row and remove the column. 4 minus 4, this is 0. Next element, remove the row, remove the column. 2 minus 12, minus 10. Remove the row, remove the column. 1 minus 6, that is minus. So, this is called cofactor matrix. This is called cofactor matrix. What is it? Minus 1, plus 1, plus 1, 2, minus 7, plus 3, 0, 10, minus 5. So, you can just check this. So, this is the cofactor directly again. Now, we learn how to find adjoint of the matrix. See, the adjoint is given by transpose of the cofactor. What is adjoint of the matrix, sir? We simply write adjoint A, ADJ of A we write. We don't have to write complete adjoint A, we simply write ADJ of A. Adjoint of A is defined as transpose of the cofactor matrix. So, whatever cofactor matrix you got, you transpose it. That is, convert rows to columns and columns to rows. So, first column becomes first row, second column becomes second row, and third column becomes third row. Hope you understand. So, that is your adjoint matrix, my dear friends. Now, what is the advantage of getting adjoint, my dear friends? We can find inverse of the matrix. See, actually definition of inverse is like that. Okay. First, let us write down definition of inverse. Okay. A square matrix A is invertible, let us say order n by n, if there exist square matrix B such that A multiplied with B or B multiplied with A gives you identity matrix. So, such a matrix B is called inverse of A, and we denote it by A inverse. That is, this B is called A inverse. This is the definition. See, always understand difference between definitions and finding inverse. This is definition of inverse of a matrix. So, B is inverse of the matrix, but how to find this inverse of the matrix? The method for finding inverse is like this. Later on, we also going to learn other method for finding inverse, okay, using Gauss-Jordan elimination method, using elementary row operation, that is different, but here we are finding by basic method. What is A inverse, sir? It is adjoint A divided by determinant of A. So, here I already know how to find adjoint. So, first find cofactor, transpose, then you are going to get adjoint. Then what about determinant of the A? So, here we also need to find determinant. See, actually determinant, I will give you shortcut later, but first of all one should definitely know this method for finding determinant. See, if you want to find determinant of the matrix, we denote it by det, sir. You take any row or you take any column. The row elements, suppose if you take row, the row elements, if you multiply with corresponding cofactors and add them, you get determinant. For example, first row elements multiply with corresponding cofactors. Here already we have cofactor matrix, no? So, I am using it. So, if you see, first row elements multiply with corresponding cofactors and add, that is 1 into minus 1 plus 2 into 1 plus 4 into 1. So, what is it? Minus 1 plus 2 plus 4. So, what is it? So, the determinant of this is 5. Actually, you can take any row or any column, sir. You can still get the determinant. You can multiply second row with corresponding cofactor. Still, you can get the determinant. For example, if you want determinant, you can multiply second row elements with corresponding cofactors. 3 into 2 plus 1 into minus 7 plus 2 into 3. So, it is 6 minus 7, that is minus 1 plus 6, which is 5. See, you always get the same thing. But generally in our examination, this cofactor matrix will not be given. So, how to find determinant generally, how you do it, this is what we follow. So, we take first row or any row, if it is having more zeros, you can take that row, or if any column is having more zeros, you can take that column. So, this first row you take 1 into cofactor of this element. What is cofactor? Signed minor, because 1 is plus sign, you get plus sign. Remove the column and remove the row. Determinant of this 1 minus 2, how much? Minus 1. Because here I am having cofactor, directly I got, otherwise this is the method. Then 2, it is 1 2 element means sign is minus sign. For the next element, sign is minus sign. So, because of that you get minus 2 into remove the column and remove the row. 3 minus 4. 3 minus 4 is 3 minus 4 is minus 1. Acha, there is a minus n, because of that directly you got the plus n. Okay. Next one, what is the next element? 4. 1 3 plus sign, 4 to be multiplied with the minor, remove the row and remove the column, 3 minus 2 which is 1. You see, same thing, directly like this we can find it. That is, you don't have to find the entire cofactor matrix. Directly if matrix A is given, you can find determinant like this, minus 1 plus 4, plus 2 plus 4. So how much? 5. Is this clear? So here we know how to find determinant. So if this matrix is given, you can find determinant like 1 multiplied with its cofactor, which is minus 1, then 2 multiplied with, then there is a minus sign, minus 2, minor is nothing but 3 minus 4 which is minus 1, then 4 multiplied with 3 minus 2 which is 1. So this is nothing but 5. So once you know determinant and once you know adjoint, then what is A inverse, Babu? Adjoint by determinant, that is 1 by determinant, that is 5 into adjoint, is minus 1, 2, 0, 1, minus 7, 10, 1, 3, minus 5. So this is how we find A inverse also. See, the determinant shortcut and adjoint shortcut I will do towards the end. Okay, so now let us see how to define rank of the matrix. Okay, for that we need to understand simple definitions. See, if you understand these things, the definition will be very clear. Okay, so let us see how to define rank of the matrix. For that we need to understand few important concepts. First of all, what is submatrix? See, whenever you are having a matrix, if you remove some rows and some columns, that matrix which is obtained is called submatrix. So see, here we are not talking about square matrix, it can be any matrix. In the matrix, if you remove some rows and some columns, the resultant matrix is called submatrix. Suppose if you are having a matrix, say 3, 4, 5, 6, 7, 8, 9, 10, 1, 3, 2, 6. Suppose if I remove this row and these two columns, the remaining matrix is a submatrix. So like that you can get many submatrices. Now when the submatrix is a square matrix, you can also find the determinant of the matrix. When submatrix is a square matrix, we can find determinant, and that determinant is called minor. So determinant of a square submatrix is called minor. So whenever you create a submatrix, if it is a square matrix, then the determinant of that square submatrix is called minor. So for example, here you remove a few rows and few columns, you got a submatrix. Okay, it's not original matrix, it may be submatrix. So let us call it as some submatrix B, and the determinant of this B is called a minor. So 3 6s 18 minus 6, which is 12. So there can be many such submatrices, sir. So any square submatrix, if you find, the determinant of that is called minor. This definition is very important. What is minor? Determinant of square submatrix. Now I'll just give you a few examples to understand this better, so that we can understand definition of rank very well. Now consider this square, this matrix, it's not square matrix, it is having how many rows? 3 rows and 4 columns. Now I can get one by one submatrices. See, for example, if I remove these 2 rows and these 3 columns, I get a submatrix. See, this is the one. Now how can I get the next one, sir? If I remove these 2 rows and these 3 columns, I get this submatrix. This is the one. Similarly, remaining submatrices you can get it. For example, if you want to get it, you have to remove these 2 rows and these 3 columns. Like that you can get it. So there are so many one by one submatrices I can get. Actually, each element of the matrix is a one by one submatrix. Each element is a one by one submatrix. Here one by one means square submatrix. And when it is a square submatrix, I can find determinant. What is determinant, sir? The determinant of it, that is minor. and they're all minor, they're all submatrices of order 1, square submatrices of order 1, we can find determinants and they are called minors. So what is determinant of this? 1. It is one of the minor of order 1. Determinant of this is 2, that is also one of the minor of order 1. Determinant of 3, determinant of 4 is 4, like that. For every element we can find determinant, and all these determinants are called minors of order 1. Now from this matrix I can also get 2 by 2 submatrices. For example, if I remove third row and these two columns, I get this square submatrix, and for this I can find determinant. 1 minus 4 is minus 3. Similarly, I can get some more square submatrices like 2 by 2 submatrices. So what is it? Suppose if I remove this column and this row, I get 1 3 2 3. What is determinant of this? 3 minus 6. 3 minus 6, how much? Minus 3. Now look at this. I remove these two columns and I remove this row. So the square submatrix you got, you can find determinant. The determinant is 0. So like that, and see, this is one more example. There are so many, I am not writing everyone, but you just need to understand what you mean by 2 by 2 submatrix. Now look here, how to get this one? I can remove this column, I can remove this column, and I can remove this row. Then 3 5 6 8. What is determinant of it? 3 8 24 minus 30, which is minus 6. So all these determinants are called minors of order 2. See, we can get 1 by 1 submatrices. They are all square matrices of order 1. Their determinants are called minors of order 1. You can get 2 by 2 submatrices, and their determinants are called minors of order 2. Similarly, we can also get minors of order 3. First, you need to find 3 by 3 submatrices. Here, if you remove this column, and no need of removing any row here, only column to be removed. So this is 3 by 3 submatrix. You can find determinant of it. Actually, here all these determinants are zeros. All 3 by 3 submatrices determinants are zeros. Okay. See, when you want to know definition of rank, that is depending on this idea only. So all the 3 by 3 submatrices determinants are 0. That is, all minors of order 3 are 0. Can you tell me what is the highest order non-zero minor? What is the highest order non-zero minor for this matrix? See, actually, you know, it is a 3 by 4 matrix. You can maximum get 3 by 3 submatrices. Square submatrices means you can maximum get 3 by 3 square submatrices. Okay, but all the 3 by 3 submatrices are having determinant 0. That is, all the minors of order 3 are having determinant 0. So 3 is not highest order non-zero minor. What is highest order non-zero minor? 2. See, of course, there may be one fellow whose determinant is 0, but not all of them are 0. So we can find a 2 by 2 submatrix whose determinant is not 0. That is, we can find a minor of order 2 which is non-zero. Therefore, the highest order non-zero minor is second order, and that is what you call it as rank of the matrix. That is what we call it as rank of this matrix, and that is the definition of rank, sir. Don't worry, we don't use this method for finding rank, but one should know it. If you want to know properties, this definition is very important. For our examination also, this definition they'll ask. So what is rank? They'll ask you, define rank of the matrix. Of course, you don't have to write the entire story which I explained. That is for our understanding. The definition is the order of highest order non-zero minor of the matrix. So you already seen the highest order non-zero minor is of second order. That order is rank. The order of highest order non-zero minor of the matrix A is called rank of the matrix. This definition involves the determinants of square submatrices. Okay. So we write rank of A, or this notation also they use row A. For rank they also use this row A notation. You can write rank of A, no problem. So what is rank, sir? The order of highest order non-zero minor of a matrix is called rank. Am I clear? So, whenever you are having a say 5 by 6 matrix, you start with all 5 by 5 submatrices. You start with all 5 by 5 submatrices, as I told you now in the examples. Then find their determinants. Then you are going to get minors of order 5. And if all of them are 0, if all of them are 0, all are zeros, then you go for 4 by 4 submatrices. Find their determinants, and their determinants are called minors of order 4. Suppose all of them are 0, then you have to go for 3 by 3 submatrices. Suppose, and of course for 3 by 3 submatrices we can find determinant, the minors of order 3. If all of them are 0, you have to go for 2 by 2 submatrices. Suppose if any one is not 0, any one of them is not 0, then rank of A will be what? 3. So you have to start with highest order minor. Okay, if all highest order, that is highest order in the sense, for this matrix highest order minor possible is 5, order 5, minor of order 5. If all the minors of order 5 are 0, you have to go for minors of order 4. Suppose if you find a minor of order 5 which is non-zero, then rank will be 5. Am I clear? So this is actually the definition. Now look at this. Suppose you are having a 5 by 7 matrix, and suppose there is a non-zero minor of order 4. See here, what I know, we are having a 4 by 4 submatrix. We are having a 4 by 4 submatrix whose determinant is not 0. Don't blindly say rank is 4, because I said about 4 by 4 submatrix determinant is non-zero. I not told you about 5 by 5 submatrix determinant. That is, I am just telling you about minor of order 4. I am just telling you about minor of order 4 is non-zero. Minor of order 4 is non-zero means rank can be 4 or more than that. Suppose if I find minor of order 5 which is non-zero, rank can be 5 also. So in this case, whenever you say that there is a non-zero minor of order some number, rank can be either 4 or more than that. And suppose this statement, you see, every minor of order 5 is 0. See, whenever you find minor of a particular orders are all 0 means rank can be less than that only. Rank can be definitely less than that. In this case, okay, every minor of order 5 is 0 means in this case rank is 4, yeah, less. 4 also I cannot guarantee, because I said minors of order 5 are all 0. I don't know about minors of order 4. I have to check them. Suppose if there is a non-zero minor of order 4 which is non-zero, then rank will be 4. So from this you can only say rank is less than or equal to 4. Sometimes the combination of these statement is also taken as definition of rank. Of course, we take it as a result. Okay, I think this one, I think that overlap this one actually. This is also taken as definition of rank. A matrix A is said to be of rank R if there exists a non-zero minor of order R. Non-zero minor of order R is there means rank can be R or more than that. And every minor of order greater than R are 0. So after that all the minors are 0 means what? Rank can be either R or less than that. So from these two, what you can combine? If you combine these two, rank A can be equal to R. So in examination, whenever they ask you what is definition of rank, this is one way you can define. The other way is this one. Rank can be defined either this way or the other. This is the important thing. It is only for defining rank, sir. Finding rank by this method is very difficult. Finding rank is actually simple. Defining rank is little involved. It's not difficult, little involved, because it is based on what? It is based on the determinant concept, submatrix and determinant of square submatrix, minors. Okay, please note that. Is that clear? Okay. What I do is, I'll just for examination purpose, let me just give you the definitions in a simplest form now. Suppose if they ask you define rank of a matrix. In examination, if they ask this question, what is the answer? The order of highest order non-zero minor is rank of the matrix. This is one definition. One more definition is rank of A is equal to R if and only if first condition, there exists a minor of non-zero minor. There exists a non-zero minor of order R, and every minor of order greater than R is 0. See, either this way you can define or this way you can define. This is how we define rank of the matrix. Now, suppose there are some examples. If you are having a 5 by 5 matrix, see, this is for square matrices. We are having a beautiful definition. These are very, very important. Okay. If we are having a 5 by 5 matrix, what do you mean by singular matrix? You know, singular means determinant is 0. Determinant is 0. See, if determinant is 0 means minor of order 5 is 0. So, rank has to be definitely less than 5 only. So, rank is less than 5 in this case. Now, A is non-singular means what, sir? Determinant is not 0. If determinant is not 0 means minor of order 5 is non-zero means rank must be equal to 5. This is very, very important, sir. So, whenever you are having a square matrix, okay, whenever you are having any square matrix, n by n square matrix, if determinant is not 0, then rank of the matrix will be n. If determinant is 0, then rank is less than n. Very, very important. And a matrix rank is 0 only when it is a 0 matrix. Suppose if there is a non-zero element is there, we have a minor of order 1 which is non-zero. So, this is very important. So, this is the statement which I already given. If you are having a square matrix of order n, rank A is equal to n. When it will happen? Rank A is equal to n if and only if, we already written this. Rank A is equal to n if and only if det A is not equal to 0. So, if det A is not equal to 0, rank A is 1. If det A is equal to 0, rank A will be less than n. Very, very important. So, we conclude this session with one very important question. They can ask you this question regularly in your examinations. The rank of a matrix is 2, then what is K? Of course, we also use other methods for this, but this for whenever the question for square matrix are given and rank is less than 3. See, it is a 3 by 3 matrix. If determinant is not 0, then rank is 3. and determinant 0, then rank is less than 3. So here you see rank is given as 2 means rank is given as less than 3. Rank is given as 2 means what? Rank is less than 3. Correct this condition. That means determinant should be equal to 0. So you can just equate the determinant to 0. And you can find the value of k here. So how to find determinant, sir? So the determinant is 1 into cofactor. Remove the remove the column and remove the row. 4k minus 30. Then see, first element plus n, next element will have minus n, because first row second column minus n. 2 into, remove the column and remove the row, 3k minus 20. Plus 3 into, remove the column, remove the row, 18 minus 16, which is 2. And this should be equal to 0, and you have to find k such that this happens. So here it is 4k minus 6k. This is 4k and this is minus 6k. So minus 2k. So here it is minus 30 plus 40. So plus 10 plus 6 is equal to 0. So it is minus 2k is equal to minus 16, yani k is equal to 8. So that is the answer. Clear? That's it. Thank you.